Good morning, students. In this section, we are going to derive an expression for the intensity of the resultant wave in Young's double slit experiment. So, last section we studied about interference and we told constructive interference and destructive interference. The point we get bright fringe is called the constructive interference, and the region where we get dark fringes are called destructive interference. So, before copying this derivation, just write a question. Derive an expression for the intensity at any point on the observation screen in Young's double slit experiment. Full stop. Hence, write the conditions for constructive and destructive interference. Okay, now listen here. So, we are going to prove the expression for the resultant intensity and we are going to derive the expression for the condition for the constructive and destructive interference. The waves with same speed, wavelength, frequency, time period and nearly equal amplitudes travelling in the same direction with constant phase difference phi. So, what I have actually written here, wavelength, frequency, time period, everything same, that means two waves are coherent. So, there are two coherent waves having constant phase difference phi. So, the first wave can be written as E1 is equal to A sin omega t and E2 is written as B sin omega t plus phi. So, there is a constant phase difference. Omega is the angular frequency, A and B are the amplitudes, E1 and E2 are the instantaneous values of electric displacements. That means instantaneous values of the amplitudes, electrical amplitudes. Now, applying the principle of superposition. So, when these two waves superimpose, you can just add them. E is equal to E1 plus E2. Now, what is E1? A sin omega t. What is E2? B sin omega t plus phi. So, we got E is equal to A sin omega t plus B sin omega t plus phi. Now, I can open this. This can be opened in the form sin A plus B. What is sin A plus B? Sin A cos B plus cos A sin B. Therefore, when I write, I am getting the thing like this. I am getting it like this. This is equal to A sin omega t, A sin omega t plus B into, this is written as sin A cos B plus cos A sin B. So, sin omega t cos phi plus cos omega t sin phi. Then you can multiply with B there, and when you rearrange, you multiply with B inside, and when you rearrange, you will get the form like this. E is equal to A plus B cos phi into sin omega t. See here, A sin omega t is there plus B sin omega t cos phi. So, from there sin omega t I take outside. So, I get A plus B cos phi sin omega t plus this B comes here when you open the bracket. So, B sin phi cos omega t. Okay. Now, this capital E is the resultant displacement, and capital A is the resultant amplitude and theta is the resultant phase difference. Okay. So, I am going to put A plus B cos phi as capital A cos theta and B sin phi I am putting it as A sin theta. This is for simplicity of our calculations. So, A plus B cos phi is A cos theta and B sin phi is written as A sin theta. Here capital A is the resultant amplitude and theta is the resultant phase difference. Therefore, our equation will be like this. Our equation will be like this: E is equal to instead of A plus B cos phi, I will write A cos theta. So, A cos theta sin omega t. Sin omega t is already here. So, A cos theta sin omega t plus instead of B sin phi, what will you write? A sin theta. A sin theta cos omega t. So, when I put these two things in the above equation, I am getting it as E is equal to A cos theta sin omega t plus A sin theta cos omega t. This is again of the form sin A plus B, right? So, I just put it as E is equal to A is common, A sin omega t plus theta. Okay. This one from here you take A common outside and this expression is of the form sin A plus B. Sin A cos B plus cos A sin B. So, instead of this I write it as A sin omega t plus theta. Okay. So, just take down till there. Now, listen to me carefully. Okay. So, E is equal to A sin omega t plus theta. That is the expression for the resultant displacement. Okay. This is the expression for the resultant displacement where A is the resultant amplitude. Now, you have these two equations, right? So, from here, how will I find the resultant amplitude? Let me take this as equation 1 and this as equation 2. You can square and add equation 1 and 2. Therefore, A square, squaring and adding equation 1 and 2. So, first I am doing equation 2. So, A square sin square theta plus A square cos square theta is equal to, see, A square sin square theta plus A square cos square theta. I am just squaring and adding both of them, okay, equal to, now LHS, B square sin square phi plus A plus B cos phi whole square. Now, this can be written as A square into sin square theta plus cos square theta, that is the LHS. Now, RHS, B square sin square phi plus, this is of the form A plus B whole square. So, A square plus B square cos square phi plus 2AB cos phi. Now, listen to me, sin square theta plus cos square theta is 1. So, you will get A square, and here this term and wait, take this term and this term, b square sin square phi plus b square cos square phi. Again sin square theta plus cos square theta is 1, so you will get only b square. So what am I getting now? A square is there plus b square plus 2ab cos phi. So this is what I am getting. A square is equal to a square plus b square plus 2ab cos phi. Then what is a? Take the root of that. So I have to take the root of that. So a is equal to the resultant amplitude. A is equal to root of a square plus b square plus 2ab cos theta. This is how you get this equation. Okay, a is equal to root of a square plus b square plus 2ab cos theta. So that is the expression for the resultant amplitude. And tan theta is b sin phi plus a plus b cos phi. So you can write it directly. And since this is the amplitude, how will I get the intensity? Intensity is directly proportional to the square of the amplitude. So please copy these things and I have to rub it and then we will go forward. This figure is not required, no need to draw this, just copy these things and plus this derivation, and the final answer will be a is equal to root of a square plus b square plus 2ab cos phi. So that is our resultant amplitude. Now we have to find the resultant intensity. Okay, finish. So resultant amplitude, as I told, it is root of a square plus b square plus 2ab cos theta. Intensity is proportional to square of the amplitude. Therefore, I proportional to a square, so I proportional to a square plus b square plus 2ab cos phi. Okay, that is the expression for the intensity. So I can also think like this. I1, listen to me what I am doing. I proportional to a square, then I1, the first intensity of the wave, can be written as k into a1 square, and I2 can be written as k into a2 square. Okay. Then I can write ka square is equal to ka1 square plus ka2 square plus 2 root ka1 root ka2 cos phi. And then I can take k common and then it will be cancelled. So a square is I, therefore I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. This is the expression for the intensity. Okay, so I wrote I proportional to a square, I1 is equal to ka1 square and I2 is equal to ka2 square. So here I will write one more thing. I is equal to ka square, and then I put there in that equation. Therefore, I will get ka1 square plus ka2 square plus 2 root ka1 root ka2 cos phi, and here and here k is there. So I take k common, cancel with this k, Therefore, I will get a square is equal to a1 square plus a2 square plus 2 root a1 a2 cos phi, and that is intensity. So, a square is I, right? So, I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. That is how you are getting the expression for the intensity. Okay. Now, condition for constructive interference and destructive interference. So, I will tell you how to copy. First you do a equal to root of a square plus b square plus 2ab cos phi, then I proportional to a square plus b square plus 2ab cos phi, and instead of removing the proportionality sign only we will put the value of k. So, after writing this, instead of a square and b square and all, you will be writing like this, and finally you will get this expression. Okay, that is how you should copy. Now, let us see the conditions for constructive and destructive interference. Constructive means where the amplitude is maximum, and destructive means where the amplitude is minimum. So, for constructive interference, I should be maximum, and I is maximum only if cos phi is equal to plus or minus 1. So, phi is equal to 2n pi. Phase difference should be 2n pi. That is the condition for constructive interference. And the corresponding path difference is written as delta. You can write p also if you want. So, path difference delta is equal to lambda by 2 pi into phi. The equation for path difference is lambda by 2 pi into phase difference. So, lambda by 2 pi into phase difference is 2n pi. Therefore, 2 pi and 2 pi cancel, n lambda. So, the condition for constructive interference is phase difference is 2n pi and path difference is n lambda. So, you will get maximum interference, which is proportional to a plus b whole square. Now, condition for destructive interference. Destructive interference is where the intensity is 0 or intensity is minimum. For that, cos phi should be minus 1. So, here we wrote cos phi should be plus 1, and for destructive interference cos phi should be minus 1, or phi is equal to 2n plus 1 into pi, where n is equal to 0, 1, 2, 3, etc. So, this is the phase difference. And how will we find the path difference? Lambda by 2 pi into phase difference. Therefore, I will get the answer as delta is equal to 2n plus 1 into lambda by 2. So, delta is equal to n lambda is for constructive interference, and delta is equal to 2n plus 1 lambda by 2 is for the destructive interference. Okay, and the destructive interference intensity is minimum, and that minimum intensity is proportional to a minus b whole square. Okay, so that's all for this. Thank you.